Hey, and welcome back to this series where we are making Tic Tac Toe games with a twist. In the previous episode we created a 3-dimensional Tic Tac Toe in Unity, and this time we're gonna use Unity again to create a Tic Tac Toe on the polar coordinates. This we will also add some depth to it, so it has some 3-dimensional feeling, since we're also using Unity. I came to this idea when I saw this website which was highlighting a Tic Tac Toe based on the polar coordinates, which got me very interested. So what is a polar grid? Well, it's actually just a grid based on circles with rays in them which are based on a specific degree. And if you like to know more about the core mathematics about this, I highly recommend you to go to khanacademy.org and follow this free course about parametric equations, polar coordinates and vector valued functions. Now without further ado, let's get started. For our grid generation, we have to divide it in two sections. The first section is the circles and the second section are the rays. There are no limitations in how many circles we want to have, and there are also no limitation in how many rays we want to have. Let's start with the generation of the circles. As I said, it doesn't matter how many circles we have, but we also have some other values like the radius in the middle and the radius of each added circle. This is how you can do that in code. But first let me show you the basic calculation. A circle size is defined by the radius. But to draw a circle, we must calculate the theta of each step. If we draw a line between each theta step multiplied by the radius, we will end up with a circle. The more steps we will calculate, the more smoothened the circle will be. We can do this multiple times to draw multiple circles. To define each radius of each circle, we can do radius plus the offset multiplied by the circle. This will lead us to multiple circles of increasing in radiuses, creating already the half of a polar grid. Now let me show you how you can really do this in the code. I am using Line Renderer to render the circles. In this case I already generated it, but I solely want to show you the algorithm of rendering the circles. To get the circles I first get the lines count, which is the amount of circles times the smoothness value to smoothen the actual circle. We can do this by calculating the angle per line, which is our 360 degrees divided by the lines count. You can see it as in this example where there is no smoothness applied. Every time if you add some smoothness to it, you will see the circle make more form and smoothen more out. And as you can see here, we are using this angle to calculate our theta, which is used to calculate our x and y position based on the radius. If you then will run this, you will see that everything is working as intended. In this case I can also show you a fun trick, which will happen if you have a failure in the mathematics. If you in this example change the angle to the lines count, you will see you will get a really weird results, resulting in all sorts of mandala figures. This is all caused because of the line renderer rendering from point A to B, and because of the angles being so far apart, it will render all over the place, resulting in these fun figures. Now we have the circles working, we can quite easily do the rays. The calculations are quite similar, but this time, instead of drawing the full circle, we will draw a line across the actual theta. To smoothen the rays, I created this count per section variable. This will define how many steps a ray will take to eventually smoothen things out. In 2 dimensions, this will not be noticeable, but I will come back to this once we add some more depth to it. If you then take a look at our step value, you can see we calculate the step between each count per section. For example, if you have a count per section of 2 and 2 circles, the step will be 0.5 and 1, and then 1.5 and 2. If you then will run this, you will see it will work as intended. Now we have the rays and circles working, we can finally focus on adding some depth. I added the depth value and calculate the centered index. Then I just multiply the centered index by the depth value and apply it to our lines positions. The reason I'm using centered index is the same as for the previous episode with the 3-dimensional Tic Tac Toe. With the centered index, the grid will always stay centered from our viewpoint, making no unnecessary blank spaces, which makes it easier to control the grid and to eventually play the Tic Tac Toe game. If you then will run this, you will see we finally have added some depth. But having this pyramid shaped depth isn't always that fun. So let's add some spare values to it to make it more circular. Making the grid spherical isn't so complicated. This is mainly because we can actually apply the same kind of logic we already have done on our circle and rays calculations. But now we have to apply it to our depth and radius. The radius needs to increase and shrink based on how close we want to get to a sphere, and the depth needs to be more modular to form an actual sphere. First we calculate the angle for the depth. The depth is calculated from 90 plus 90 times the sphere value, because this way it will be along a quarter of a circle radius. This quarter is only along the x value, making it possible for us to make a transition from depth only to an actual sphere. Then we calculate the depth data in the same way as we are doing all the time. We check if we want to make a grid spherical, and if so, we apply a circular calculation to the offset. The reason we use sinus instead of cosinus is because of the 90 degrees angle calculation along the x side. Then we apply the depth if there is a spherical value set and multiply our depth by the cosinus pi times I divided by the size. This might sound very complicated, but it's actually the data along a 180 degrees based on the amount of circles we have. I divided by the size will be from 0 to 1. Multiply this by pi and get the cosinus of this, and you will complete the half circle. Have this with the quarter circle of our offset together with the depth we have created, and we will end up with a spherical shape. If this is still hard to understand, I highly recommend you to play with the code and see how all the values behave. For me, this always works the best to actually understand how it all works. If we then run this, you can see we can make everything more spherical. To me personally, this makes it look much better and brings much more opportunities to this Tic Tac Toe game.
Let's see if I can be the best. Start something from the ground up.
You can use this exact same logic on our race as well, which I will just fast forward now. Also, as you can see now, the steps between the rays will come perfect in place. Now we have our grid fully working, we can place our hitboxes to play. For this I wrote a separate method, which is called at the end of each ray drawn. We give all the values, including the angle of this ray and the ray index. We then do all the same calculations as the ray, but we skip the steps for the smoothing. This way we find each time the ray is crossing the circle and positioning our hitbox there. For the hitbox I chose to use a simple sphere. I then created this simple script, which scales the sphere if we hover over it. The hitbox will call the game manager when the hitbox is pressed, and it will then place an X or O based on whose turn it is in the game manager. The game manager is actually quite simple. It only holds data to play the game, and it holds the hitboxes based on the X and Y value. You can see the code here. If we then will run this, you will finally see the full grid with the hitboxes. You can hover over the hitboxes to see them responding, and when you actually press, they will place an X or O. For this X and O, I applied this simple script which I found on the forums to make it always rotate towards the camera. Now with all the hitboxes set, we must focus on the patterns. The code for the pattern finding is very similar to all the previous episodes, so if you haven't seen them yet, please check them out. The only difference is that our X needs to have a continuous search. This is because different from the regular tic-tac-toe, the begin and end on the X row can connect together. If you see this example of your regular tic-tac-toe, you will see on the X row there is an ending. But if you check on a circular, there is no ending, because it keeps on continuing, and in this case 1, 0 and 11 can still connect. When the game is ended, I imported this end animation from the previous episode to show who is the winner. Now let me show you all the patterns. The first pattern is the horizontal pattern. The second pattern is the vertical pattern. The third pattern is the diagonal from the bottom left to the top right. And the last is the diagonal from the bottom right to the top left. I can also show you this quick example to show you that the continuous X search is working by searching from 0 to 11 to 10. Now you can just try to play around with the shapes and play on all sorts of different polar grids. As example, you can take this without the spherical values, or you can go all out with the spherical values like this. It's all up to you. What you also can do is even try to go further. You can, for example, try to make a world inside of the sphere, so you can make a tic-tac-toe around the universe. I made this quick mock-up to show you what I mean, but I hope you also understand there are lots of opportunities to create fun games with this. So this is the end of this tutorial. I really hope you enjoyed it, and I hope it made you try to go and create your own polar grid. Please consider giving me a like and subscribe, and put up the bell notification to get notified for the next episode. If there are any questions, feel free to ask in the comments below or send me a direct message on Instagram. All the links are in the description, and I hope to see you in the next video. Goodbye!